Hi, this is Professor Bucklehide, and I'm making this video to go over a problem that we did in class about relative velocity. In this problem, we have a river that has a current that's moving to the right, and we have us right here, and we want to cross the river directly to a point directly across from us. So we can be over here and be happy. We're going to use these variables to indicate our velocities, our velocity relative to the ground, our velocity relative to the water, or the water's velocity relative to the ground, and we can use our Galilean velocity transformation equation to relate these. So our velocity relative to the ground has to be equal to our velocity relative to the water plus the velocity of the water relative to the ground. So we're given that our swimming speed is 2.4 meters per second, and that's relative to the water. So that's like how fast we can push off the water. And there's also a water current running 1.1 meters per second to the right. So ultimately, we want to figure out how long it will take to cross the river if it's 52 meters wide. So, okay, we want to go straight across the river. If we try to swim straight across the river, so that's velocity of u relative to the water. If we aim for straight across the river, we're unfortunately going to get swept off to the side by the current. So that's the velocity of the water relative to the ground. And our total velocity will be the sum of these two. So that will be the velocity of us relative to the ground. And that's not what we want, right? If we did that, we'd end up somewhere over here. And that's not what we want. So that's not what we want. So we're not going to do that. Delete that. So instead, we have to try to swim a little bit against the current, right? So we have to aim sort of off at some angle. So our velocity relative to the water has to be off at some angle so that when we take into account the velocity of the current, or the velocity of the water relative to the ground, the total velocity of us relative to the ground is going to be right across the river where we want it, right there. Now in this case, because the current is going completely to the right, and we want to go directly across the river, this is going to be a nice right triangle, where that's our perpendicular angle. And so it should actually be pretty easy to calculate this. So our speed relative to the water, that's this 2.4 meters per second. The velocity of the water relative to the ground is the 1.1 meters per second. And so it should be easy to calculate what this third side of the triangle is, just from the Pythagorean theorem. So our velocity relative to the ground should equal square root of 2.4 meters per second squared minus 1.1 meters per second squared. Oops. And so that's going to turn out to be 2.1 meters per second. So now we know how fast we're going to be crossing the river relative to the ground, and so we can calculate. We know distance is velocity times time, so if we want to find the time that it takes, we just need to know the distance over the velocity. And for us crossing the river, that's just 52 meters divided by 2.1 meters per second, and it should give you 24 seconds is the time it should take you to cross the river. Okay, now we make some assumptions when we do this. So one of the assumptions that we make is that the person crossing the river is really smart and skilled at crossing rivers and currents, and that they're going to choose this angle exactly perfectly. You know, in reality, you could imagine someone trying to cross the river. They get off one direction, they correct, and then, you know, if you do that kind of path, it's obviously not going to be as fast. So we have to assume that the person making this trip is really skilled. And that seems like a reasonable assumption for this problem. We also assume they're not going to mess up, right? Like, what if the person goes way too far to the left? Now, even with the current, their final velocities, they're not going to end up at the point across the river. They're going to end up too far to the left. On the other hand, if they don't angle it enough, now you're going to end up way over here. So if you mess up as the swimmer, it's pretty easy to accidentally end up over here or over here. Have a good night.